So we've pretty much done everything to get ready to figure out how to find the values of any trig expressions of of any angle, whether it's a calculator or whether it's without a calculator, and solving equations. This next lesson will allow us to find certain trig ratios of certain angles, okay? Without having to use a calculator, okay? With using what we call the unit circle, which is basically you're taking a right triangle, putting it inside a circle, and remember we used right triangles to find trig ratios. So we're going to use the unit circle and the triangles to find the trig values of like common angles, 30 degrees, 60 degrees, 45 degrees, and all the multiples. Anyway, unit circle. Right? Well, unit means one. So it's got a radius of 1 unit. We don't know what the units are, it doesn't matter. And the center of the circle is at the origin 0, 0. Okay? So what we can do is we can put triangles, right triangles, inside the unit circle so that they touch the outside of the circle. So like if I want to put a right triangle in here, that's the hypotenuse I'm going to draw. I'm going to draw it from the center to any point on the circle. I know this is 1 unit because I'm told it has a radius of 1. To finish the right triangle, vertical segment, which represents the length of y, whatever this point is, x comma y. And this completes the right triangle, and this length will be whatever the value of x is here. So I could place one like that. I could place one like this. I could place one like that. I could place one like that. But I place them so that the hypotenuse of the right triangle I put inside the unit circle is always going to be 1. Okay? Because if it's 1, and if I know this point, I can actually figure out all the trig ratios exactly without having to use a calculator. But before we get into that, so basically the unit circle formula is, remember, Pythagoras is a squared plus b squared equals c squared. Where a is one leg, b is the other leg, c is the hypotenuse. Well, here, instead of a, I'm using the length of x. So x squared plus, instead of b, I'm using the length y. Y squared equals the hypotenuse squared. Well, the hypotenuse, whenever I put a right triangle inside the unit circle, is always 1. So 1 squared is 1. So what does this mean? This means that if you want to tell if a point is on this circle, okay, then its x coordinate squared plus its y coordinate squared must equal 1. Like if I said, for example, let's say that's the point 1, comma 2. Can I fit that into the unit circle? No, because 1 squared is, plus 2 squared is 4. So if I add those, I get 5, right? It has to equal 1. Okay, so this is not on the unit circle. That does not have hypotenuse of 1 if I do Pythagoras. Why does it keep doing it? So for this example, to tell if it's on the unit circle, well, this is the x coordinate. This is the y coordinate. I just need to know, does x squared plus y squared equal 1? Because the unit circle formula is x squared plus y squared equals 1. I want to know if root 3 over 2 times itself plus 1/2 times itself equals 1. And I'm going to put a question mark over the equal sign because I don't know if it equals yet. Well, what is root 3 over 2 times itself? 3 over 4. What is 1/2 times itself? 1 over 4. Well, 3 over 4 plus 1 over 4 does equal 1. So therefore, the point is on the unit circle. If it didn't equal 1, then it's not on the unit circle. We want to know points on the unit circle because that allows us to find the trig values of it, the trig ratios, and it allows us to solve trig equations. Here's a second type of example you may see. You're told that this point, but you're not told the y coordinate, is on the unit circle. How would you figure out what y is? Right, well, the x coordinate and the y coordinate, -3/5 squared plus whatever this missing y coordinate is squared must equal 1. So yes, you do 1 minus -3/5 squared. So what is -3 over 5 squared? 9 over 25 plus y squared is equal to 1. But I'm going to make life easier on myself because I'm going to have to subtract a fraction over 25, right? How do you write this as a fraction over 25? 25 over 25. Now to get y squared by itself, I subtract both sides by 9 over 25. Subtract by 9 over 25. And I get y squared is equal to 16 over 25. So y is equal to, does anybody, okay, I heard square root. It works out to 4 over 5, but that's not the only answer. Remember, when you solve an equation like this, you have to take the positive and negative square root of 16 over 25, not just the positive. We learned these last year. So my answers, I have 2 of them. It could be plus 4 over 5, which is pretty much all that you got. But remember, it could also be negative because -4 over 5 times -4 over 5 is 16 over 25. Watch out for that. Whenever you solve a simple quadratic equation, plus minus square root, not just square root. Because notice it says find all values of y. That kind of suggests that there's more than 1. So therefore, the point -3 over 5, comma, positive 4 over 5 would be on the unit circle. So would the point -3 over 5, -4 over 5. So there's a whole bunch of points that are on the unit circle. Infinite number of points. As long as the x squared plus the y squared is equal to 1. Okay? But I only want to look at certain points on the unit circle. Because remember, when we do trig, when you guys did trig in grade 10, we used any angle from 0 to 90 degrees, okay? And we used the calculator. There are many angles you can find without a calculator, and it's the common angles. And by common angles, I don't mean 37.5 degrees. That's not a common angle, okay? 45 degrees is a common angle. So is 30, so is 60, so is 90, okay? You can probably look around this room and find me an example of each type of angle. Can you find me an angle somewhere in this room that looks like it's 45 degrees? What about these ones? These triangles, what do they look like? Actually, they look like they're 60 degrees because it's an equilateral triangle, which means all the angles are the same. Which means that this angle here would be 30. There's two 30-degree angles there. 45 degrees, what about over there? Or the X's? The X's there. They kind of look like they're 45 degrees. They look pretty close. And then 90 degrees, anything that's perpendicular. So these are common angles we use. That's what I mean by common angles. So what I need to do is I need some triangles that have 45, 30, and 60-degree measures in them, but also have a hypotenuse of 1. Okay? That allows me to put it inside the unit circle and use that formula. Well, here's a 45. So I've created a 45-degree, 45-degree, 90 angle. And I'm going to call this side 1. Why is this side also 1? Because that's, oh, do you remember the name of the type of triangle where two of the angles are equal? Oh, sorry, I'm spelling it to myself. Isosceles. Okay. So this angle's 1, or this length is 1, this length is 1. How did I get this? It's 1 squared plus 1 squared, and then take the square root is square root 2. Right. But I need a similar triangle where this is 1. I need a proportional triangle where this is 1. Okay. How do I get from root 2 to 1? Like, okay, let's say I had this. Let's say this was 10. No, all right. Let's say this was 6, 8, 10. And I want to make a similar triangle where this is 5. What would the legs be? Divide by 2, right? Because I'm making a proportionally smaller sample, so I don't subtract 5 from each. That's not proportion. Proportion is what you divide. So I divide by 2, which means I must divide this by 2, which means I must divide this by 2. That's a similar triangle that's proportionally small. But what you have to divide this by? Root 2. Which means you got to divide every side by root 2. Root 2 divided root 2 is 1, which is what I want. Okay, remember this is still 45 degrees, and this is still 45 degrees. 1 divided by root 2 is 1 over root 2. But if you remember from grade 11, we never had a square root in the denominator. Remember what we had to multiply by? Root 2 over root 2. And that will give me a simplified answer of root 2 over 2. That means this one's the same. I don't have to do all over again. That one's the same. So when the angles are 45 degrees, and I want to put it in the unit circle, I need an x value of root 2 over 2, and I need a y value of root 2 over 2. What happens if I want 30 or 60? Anybody still do this? Well, here's what I do. I'm going to make an equilateral triangle. Okay, I'm going to start by making this, and I'm going to name each. I'm going to say, okay, let's say each side is 2. Why did I say 2? Because if I cut the equilateral triangle in half, I get a right triangle with 30 and 60 degree angles. So this is 2, it's given. This, if I cut it in half, is half of 2, which is 1. And then I can find this by Pythagoras. But again, I don't want a hypotenuse of 2. I want 1. So what do I have to do? Divide 2, which means I got to divide everything by 2. So root 3 divided 2 is just root 3 divided 2. And 1 divided 2, I just leave as 1 divided 2, or 1 half. And remember, this is 60 degrees. And that's 30 degrees. So if I put that in the unit circle, the x-coordinate is going to be 1 half, and the y-coordinate is going to be root 3 over 2. If I flip it like this, let's say that what I'm going to do is I'm going to drop it and then flip it so that the 30 is on the lower right. What are the lengths again? Which one is which? Which one is 1? Here, which one's a half? Vertical or horizontal? Vertical. Vertical. And the horizontal would be that one. So the x-coordinate at 30 would be root 3 over 2. The y-coordinate would be 1 half. Okay. So now what I'm going to do is I'm going to take those 3 triangles and we're going to put them in the unit circle. And as soon as we do that, we can find trig ratios. Sorry, as soon as we do that, we can find points on the unit circle, which means we can find trig ratios, which means we can solve trig equations. So here, remember what we did? We just created a triangle on the previous page. This is the unit circle, so this was 1. What were these lengths again? Root 2 over 2 and root 2 over 2, which means that this point here is the point root 2 over 2, the x, comma root 2 over 2, the y. Which means whenever you have a 45 degree angle, the point on the unit circle is always going to be that. If we take the other ones, if we plug the 30 degree one in, remember, we plug that in, that's 60 degrees. What are the lengths again? Well, what's this length?
1.
Always 1. What's this one? Root 3 over 2. It's, remember, root 3 over 2 is bigger than 1 half. It's larger. So it must represent the longer side. And this is a half. Which means that this point is root 3 over 2 on the 1 over 2. And then this one is the same triangle, except we flip it around so that the 60 degrees becomes the central angle. Well, this is still 1. What's this? Half. And this is root 3 over 2, which means that this is the point 1 half comma root 3 over 2. So you just found 3 of them.
Right?
We did this last year. Okay. All I'm doing is I'm taking the triangles I created on the previous page and plugging them in here. That's all I'm doing. Okay. All right. So you now know if an angle is 30 degrees, what point it is on the unit circle. You now know it for 45. You now know it for 60. And those were ones we learned last year. So we know 30 degrees, we know 45 degrees, and we know 60 degrees. 30 degrees, the point on the unit circle was root 3 over 2, comma 1/2, according to the diagram above. 45 degrees, root 2 over 2 for the x, and the same for the y. And 60 degrees is the reverse of 30. 1/2, comma root 3 over 2. But now we're adding radians. Like this is grade 11. This is grade 12. What is 30 degrees? I'm shaking the head. 30 degrees in radians. Don't we times it by 5 or 180? To convert from degrees to radians. So that gives us 30 pi over 80, which is 5 or 6. What's that one? 45 pi over 180, which reduces to, what's 180 divided 45? You take a guess? 4 is right. $60 degrees times pi over 180, that's a little easier to produce. Pi over 3. Don't worry, you'll remember these. Okay, you will. The only other 2 I want to add are 0 degrees, which is really easy in radians. 0. And 90 degrees, which if I times by pi over 180, I get 9 pi over 180, which becomes pi over 2. What are the points on the unit circle when we have, and I'll just use this as an example, 0 degree angle? Well, doesn't a 0 degree angle, the initial arm is there and so is the terminal arm? What point is this on the unit circle that it ends at? 1, 0, because this length is 1. So when we don't have an angle, or it's 0 degrees, the point will be 1, 0, 1. If we have a 90 degree angle, it ends up here. 0, 1. And it's on the unit circle because this squared plus this squared equals 1. Now it's all connected. It's crazy. Once you got these ones, you can get a whole bunch of other ones. This is where we do the unit circle, and we're not going to do the next 4 pages, because we're going to go straight to the unit circle, which you should have. Please tell me you have it. Flip. No. 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 Okay. So I'm going to use 4 different colors. Let's start with the ones that we just did, the 5. Here's the first one we did. Degrees or what in radians? And what was the point on the unit circle? Now 0 degrees is also 180. 180 is here. 360. So it's the same thing. And what's 360 in radians? 2pi. So it's the same point on the unit circle. Then we did 90 degrees. Here's 90 degrees. What was it in radians? 2. And the point on the unit circle in degrees are pi over 2? 1. Now, we also did 30 degrees, which was what in radians? Pi over 6. And what was the point on the unit circle? It was the long value over the short one.
Over 2, well, it's 1/2.
1/2 is not bigger than root 3 over 2. Root 3 over 2 is always bigger than 1/2. So it's the longer one than the shorter one. 45 degrees. Pi over 4. What was the point on the unit circle? Same values, root 2 over 2, root 2 over 2. And finally, the 60-degree angle, which is what in radians? Pi over 3, was the short x and then the long x. The shorter value is 1/2. The bigger value is root 3 over 2. That's what we've done. That's what we did on the table. And that comes from the triangles we created and fit into the unit circle. Now, how do we go beyond? Well, let's look at this one. What would this angle be? Remember, this is always the starting arm, 180. I'm going to put it in green because it's actually part of the green family, 0, 90, 180. What's 180 in radians? 1 pi. And what would this point be on the unit circle? -1, 0, because it's a length of -1 and no y length. Let's do the one that goes straight down. That's 270 degrees. But what is that in radians? Remember, we've got 0 and then a pi over 2. And then 2 pi over 2, which is just pi. So it makes sense that this is 3 pi over 2. And what's the point on the unit circle? 0, -1. Okay. Let's look at the segment in quadrant 2 that looks like it is similar to the 45-degree one in quadrant 1. Which of the 3? The middle one, right? So we need the angle. Well, what's the angle in degrees? How much is it from here to here? 135. What is its angle going to be in radians? It's going to be the same denominator as this one. So it's going to be 4. The question is, how many pi's go up top? This is 1 pi over 4. 2 pi over 4 is this. 4 pi over 4 is this. So what do you think this one is? 3 pi. And what would be the point on the unit circle? Same points except one would be negative, right? Or same values except one would be negative. So negative root 2 over 2, comma positive root 2 over 2. Let's take the related angle in the third quadrant, which would be this one. How much is it from here all the way around to there? Well, it's 180, and then it's another 45. 225 degrees. And how many radians is that? Again, it's going to be over 4. Right, because this is 3 pi over 4, this is 4 pi over 4, this is 5 pi over 4. And the values are going to be the same root 2 over 2's, except they're both negative. And then we go to this, which is what in degrees? 315. There's a couple ways you can think of it. 90, 180, 270, and another 45 degrees. Or all the way around is 360, take away 45. Either one of those gets you 315. In radians, denominator's 4, which makes sense because this is 6 pi over 4. This must be 7 pi over 4 because this is 8 pi over 4, which is 2 pi. And the points, or sorry, the values of the coordinates, still root 2 over 2, but which ones, if not both, are negative? The second. So that's the family. We either call it the 45-degree family or the pi over 4 family. This one, the green, as we usually call it, pi over 2 family. Let's go into the pi over 6 family. Well, the related angle would be this one. Remember, it's 30 degrees from here to here. How much would it be from here to here? 150. And for the radians, remember, we're dealing with sixths now. The question is, how many pi's? How'd you get 5 pi? What's that? So, well, 6 pi over 6's, isn't that pi? Right, so 6 pi over 6, that's a little too big. So it's got to be a 1 less pi. So 5 pi over 6. And the point is going to have these values, except just get the negatives right. Which one, if not both, are going to be negative? First one. This one is part of the pi over 6 family or 30-degree family in quadrant 3. What is it in degrees? Well, it'd be 180 plus another 30. 210. In radians, denominator 6, question is how many pi's? Remember, this is 6 pi over 6. This must be a little bigger. So we'll just bump it up by 1 pi. And it's going to be root 3 over 2 and 1/2, both negative. And finally, this is the related angle in quadrant 4 of the 33 or pi over 6 family. How many degrees? 330. I know it's going to be a denominator of 6 in radians. Right, because if you think 12 pi over 6 is 2 pi. So it's got to be a little, remember this is 12 pi over 6. So it's going to be a little bit less. And then we've got root 3 over 2 and negative 1. Finally, the pi over 3 or 60-degree family. So we've got 3 angles left to do. Well, what would the measure of this angle be? Remember, we always start on the positive x to here. 120. And notice 60 degrees is over 3, so this is going to be over 3. So it's going to be 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Which one is it going to be? Because if you think 3 pi over 3, that's 1 pi. 3 pi over 3 is here. It's less. It's got to be 2 pi over 3. Okay. And the points? So notice all the points on the unit circle, there's only 3 values, or sorry, 5 values to remember. 1/2, root 2 over 2, root 3 over 2, and then 0 or 1. And some one or both may be negative, depending on what angle we're talking about. So we go here. In degrees, well, we got 180 and then another 60, 40. We know it's going to be a denominator of 3 in radians. 4 pi over 3. And the point, it's going to be the 1/2 first, then the root 3 over 2, but because we're in quadrant 3, correct, both negative. And finally, this angle here, 300 degrees, because we could look at it like all the way around is 360 and then take away 60. It's going to be over 3, 5 pi over 3, because 6 pi over 3 is 2 pi. So it has to be less than 6 pi over 3. And then it's the short, or the smaller number first, and then the bigger number, but as a negative because we're in quadrant 4. That is the unit circle. You can see, I usually don't, I mean, there are so many different ways that you can research out there how to remember this. Like there's songs, there's using your hands like this. Notice if I put my hand like that, covered all the angles in the first quadrant. Okay. You can see patterns. Like they're all over 2, aren't they? All the ones out here, they're all over 2. Notice this is root 3, root 2, and technically this is root 1. And this is root 1, root 2, root 3. So maybe you see the pattern there to remember it. The lower it is to the x-axis, the bigger the denominator is in radians. So like if it's low, it's high 6. If it's in the middle, it's 4. If it's high, it's 3. Different ways to remember. Okay. So just to finish this up, oh, because I'm in the wrong file. That's why. There we go. Wonder how much you can do without the unit circle. All this is, I give you the angle, you tell me the point. And you obviously can use the unit circle as a reference, but test and exam, you don't get it. All you get is a blank one. You would get a blank one, like the one I gave you before we filled it in. Okay? So all you're telling me here are points. Pi over 4. Okay, I'm waiting for the point. What's the point on the unit circle when the angle's pi over 4? What's this root 2 I'm hearing? Root 2 over 2, comma, root 2 over 2. $60. That's the one up here. Half, and then the bigger one, root 3 over 2. Like, this is what I do when I do these things, is I visualize where the angle is on the unit circle. So here's where I always start. So pi is here. -1, 0. Five pi over 6. Well, 180 is 6 pi over 6, but it's a little less. So it's going to be the long value, or the bigger value, on the short value. -√3 over 2. Or pi over 3, well, the pi over 3 is up here. Here's 2 pi over 3. Here's 4 pi over 3. That's the one where it's the smaller length and the bigger, both negative. -1/2, common -√3 and 2. Ooh, negative pi over 6. That one throws a bit of a wrench into it. Well, think about it. Okay, here's the start. But instead of going pi over 6, I'm going pi over 6. What's that equal to? Which angle on the unit circle is that equivalent to? Okay, all right. We're okay. We're okay. Let's just all remain calm. Take a deep breath. I know I am. Aren't you going like that? So isn't it the same as negative? Isn't it the same as 11 pi over 6? How's another way you could find this? I have no idea if that was a proper English sentence or not that I just said. It didn't sound like it. Think of it this way. This is not between 0 and 2 pi, is it? So I need to find its coterminal angle. So add a 2 pi, which is the same as 2 pi over in 6 is the same as 12 pi over 6. So what's -1 pi over 6 plus 12 pi over 6? 11 pi over 6. That one you do know. So if it's not an angle that's on the unit circle that we did, either add or subtract 2 pi's to get an angle, to get a coterminal angle. And this one, what was the point on the unit circle? 3 over 2 comma -1/2. This is an angle on the unit circle. 7 pi over 4. Well, here's pi over 4. 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4.
No.
Right, root 2 over 2. Negative root 2 over 2. Pi over 2 is straight up. 0, 1. This one's not on the unit circle. It's too big, which means I got to take away a 2 pi. But I want to express 2 pi as a fraction over 3. So I'm going to take away 2 pi, which as a fraction over 3 is the same as 6 pi over 3. So 8 pi over 3 minus 6 pi over 3 gives me 2 pi over 3, which is on the unit circle. Negative 1 over 2, root 3 over 2. Excellent. Yep. Because I changed 2 pi to a fraction over 3. Right? Like in order to subtract 2 pi, I have to make it an equivalent fraction over 3. You're good? Just like this one, it's too small, I got to add a 2 pi. Well, how many 2 pi over 1 is the same as how many pi's over 4? 8. So this becomes 8 pi over 4. So this plus this gives me pi, or I'm looking for the point at 3 pi over 4. Remember, the pi over 4s are the root 2 over 2s. Well, pi over 4, 2 pi over 4, 3 pi over 4. Negative root 2 over 2, positive root 2 over 2. This one's too big. Take away a 2 pi, what do I get? So at what point on the unit circle is 2 pi? 1, 0. I got a little bit of time, I'll finish this up. Okay. So that's given the angle, you write the point. What about if you work backwards? You're given the point, you have to find the angle. So we'll just do these. These go a little quicker. 1/2 root 3 over 2. So this is what, I think like this. 1/2 is the short, and then root 3 over 2 is the longer side, so it must be up here. 60 degrees, or in radians, pi over 3. This one goes straight in the middle in quadrant 2. 135, or whether it's the pi over 4 family, 3 pi over 2. 1, 0 is here. What angle? So 0 or 360, and then in radians, 0, 2 pi. This one tells me quadrant 3 right away. And it's the longer one first, and then the shorter side. So it's here. 210, 756. This is quadrant 4, short side first, then the longer side, so I'm down here. 300 degrees. How many pi's over 3? 5, 5. And finally, 0, -1 is all the way down here. 270 or good. Okay. So the last step sort of is to, okay, now that we know certain points on the unit circle given certain angles, we can apply that to trig. So for Monday, 4.3, exercise 4.3, because I'd like to get started on 4.4 on Friday.